We as researchers need to start challenging ourselves to think about conservation as a two-step process. First, you have the research project. You collect the data and eventually either publish the results or create reports and send them up the food chain. But then what? Where does that information go? For a lot of us, it remains in our sea turtle community. While this is an important step in the conservation process, it's only half the puzzle. In order to really drive conservation, we not only have to understand more about sea turtles and how they behave, but we have to modify human behaviors. So how do we convert these data into educational messages to help get people invested? One way is to start by working with some of the best scientists in the world. Kids. So how do we take esoteric concepts and convert them to lessons that K-12 students will understand? Over the last few years, In-Water Research Group has come up with some ways to do exactly this while working with limited resources. What we came up with was an all-inclusive traveling trunk program that teachers could borrow for free. We began by working with our local school district officials to see what teachers needed, what resources they were working with, and how to hit the important state education standards while teaching students about sea turtle conservation through hands-on lessons. In order to engage students and get them invested in conservation, we had to create and maintain a level of authenticity for our lessons. Students are inherently interested in the work that we do, and by allowing them to step into the roles we take on every day, they are more likely to retain the information and share it with their families. By mirroring our research, we are creating the next generation of scientists and responsible environmental stewards. Our first program, Traveling Turtles, launched in 2015 with much success. Lessons included an introduction to sea turtles, where students learn about the different sea turtle species and what makes each one unique. They learn about adaptations, habitats, and the nesting process while acting as sea turtles themselves. We explain population dynamics and sampling through a game that gets students out of their seats and into the role of both turtle and biologists. Their classroom becomes a lagoon, in which biologists are looking to capture, document, and release sea turtles to get a snapshot of this particular population. Our final lesson allows students to step into the role of biologists as they work up their own turtle and learn how to collect data. This type of lesson is inquiry-based and student-driven, ensuring the take-home messages last longer and have more of an impact. Students have now just learned all about sea turtles, how to conduct actual research and why it's important, as well as the threats sea turtles face and how students can help. All this while students are hitting their state standards and having fun. With the success of Traveling Turtles, we decided to create another program with the same infrastructure that touched on a critical issue facing sea turtles today: lighting. How can we teach this in a way that will drive the message home while educating students through state standards? 3rd to 8th grade students are required to learn about the different forms of energy and how they behave. This is a perfect conduit for us to discuss lighting and sky glow. Through our Darker Skies, Darker Beaches program, students learn about light energy and the different characteristics of what makes lighting sea turtle friendly. Groups of students must build their own circuit to light an LED bulb mounted on a wall. This will simulate a home with an outdoor light that must be retrofitted to become sea turtle friendly. Students must now act as engineers using the engineering design process to create a fixture that will both block the light from the beach while creating a safely lit path for the homeowner. They must use provided raw materials, each of which is associated with a cost based on its quality, and maintain a budget. Prototypes must be effective, cost-efficient, and aesthetically pleasing. This encourages them to look at lighting from multiple stakeholderships. They must think like a sea turtle, a biologist, an engineer, and a homeowner. These multiple perspectives cement the importance of sea turtle-friendly lighting while addressing the concerns and questions that arise when this topic is discussed. The best part about this lesson is that students get creative in a systematic way and all come up with different solutions. Because they've developed it themselves, they become greatly invested in the outcome. Our programs were successful locally, reaching thousands of students each school year, but we wanted to expand our geographic reach to the rest of Florida. We developed partnerships with other organizations like ours with limited resources that would benefit from a free program they could offer to their communities. We replicated our trunk programs and donated them to these partners who now offer them to teachers in their local school districts.
What I really enjoyed about the program was that it aligned to a lot of our standards. So we are a standards-based instructional school here. And I think adaptations were one of the big things that they learned, characteristics and the plastic situation and the lighting situation. So both of the trunks really encapsulated all of those ideas and were so kid-friendly that we had a good time and they were learning, and I don't even think they realized it.
Our students and our teachers have gotten together. The teachers have gotten professional development that made them even stronger in the classroom, but being able to pull our standards and bring real life experiences into the classroom and make our students real scientists.